So if you're here, it's because you want to learn a little bit more about the 7-layer OSI model. And if you do work in IT or plan to work in IT, I'm going to be covering the infamous layer 8 at the end, so make sure you stick around for that. So the first layer we're going to discuss is layer 7, which is the application layer. The application layer is the only layer that you actually interact with as an end user. If you're watching this video, then you're watching it through a web browser or through an app on your phone. That application that you're using is what initiated the interaction or communication between you and the application layer, most likely through HTTPS. It's important to note that the actual application you used is not part of the application layer, just the protocols that application used to transmit the data. I know that can be kind of confusing. The application is not part of the application layer, but it's an important distinction to remember. Another example is an email client. So the actual email client is not part of the application layer, but the protocols it uses, SMTP and IMAP, are part of the application layer. And there are a ton more protocols that are part of this layer. These are just a couple main ones. If you want to see a real-life example of this layer 7 request, you can just right-click in your browser on any web page, select Inspect. Once you get on the Network tab, you can see the headers that were sent. So we can see here the HTTPS request that was sent with layer 7 headers. So that's just one example of a layer 7 request. So now that we've covered layer 7, the next layer is layer 6, and that is the presentation layer.
PowerPoint, PowerPoint, PowerPoint.
The presentation layer's main responsibility is presenting the data in a way that can be used by the application layer. As an example, when the data uses encryption, the presentation layer is responsible for encrypting and decrypting this data. So before the encrypted data can be viewed by you in your application, layer 6 must decrypt it and make it presentable so that you can view it. Compression is also handled by layer 6, and this is what's used to improve the speed and efficiency of the data being transferred by minimizing the amount of data that's sent. So as the name implies, presentation layer, you can think of this layer as presenting the data it receives in a format that the application layer can then display to you. So following the presentation layer, that brings us to layer 5, which is the session layer. The session layer is responsible for opening and closing the connection between two devices. The time when communication is opened until the time it is closed is known as the session. The session layer ensures the session stays open long enough to complete the data transfer and then promptly close it to avoid wasting resources. Another great feature of the session layer is something we can all appreciate, which is checkpoints. So let's say you're downloading a 500 megabyte file. If there are disconnects after only transferring 267 megabytes, the session layer will help save you time by resuming from the most recent checkpoint. These checkpoints might have been every 10 megabytes, allowing you to resume from the 260 megabyte checkpoint. Without these checkpoints, you would be starting your download all the way from the beginning. Let's get a round of applause for the session layer. So before we move on to layer 4, I want to mention that the previous 3 layers we just discussed could be grouped as application-oriented layers. The next layers we're about to discuss are network layers and my personal favorites. So that brings us to layer 4, which is the transport layer. Layer 4 finally starts to take some responsibility and is responsible for the end-to-end communication between devices. So the transport layer takes the data it receives from layer 5, the session layer, and breaks that data up into segments. So now that we have these segments, there are 2 main protocols used to facilitate the delivery of this data. Those are TCP and UDP. TCP stands for Transmission Control Protocol. TCP is a connection-oriented protocol which guarantees the delivery of the message. When the sender sends data, the recipient must acknowledge that it received the data. The data segments can be sent and received in a random order, but they are then rearranged in the correct sequence to get the original file. For this reason, it's seen as a reliable protocol. If the data was sent but never acknowledged by the recipient, then that data is seen as lost and it is retransmitted by the sender. Some common uses for this are web browsing and file transfers. You want to make sure that if you're downloading a software update, you're getting that exact software and not something that's corrupted or missing pieces. You can think of TCP as similar to when you need to sign for a package before you can receive it. The sender knows you received that package. So that brings us to UDP, and UDP stands for User Datagram Protocol. So while TCP is a connection-oriented protocol, UDP is a connectionless-oriented protocol, where speed is the main concern. No prior connection is required, and sent data is not required to be put back in the correct sequence. The receiver does not acknowledge receipt of the data, and the sender does not wait for any acknowledgement from the receiver that it received the data. The sender just keeps pushing data, and this ensures the fastest speed possible. This is extremely useful for video streaming. You might notice while watching YouTube or Netflix, there are some weird pixels or blips in the picture. This is usually because some of the data was lost when in transfer. And since UDP doesn't care about you receiving the data, it just keeps sending it and moves on. As an end user, you're going to be much more tolerant of a couple blips on the screen as compared to a video constantly buffering. You can think of UDP as that delivery that just got thrown at your house, no confirmation that you got it. You might have heard of ports when it comes to networking, such as 80 and 443, which are HTTP and HTTPS respectively. Layer 4 is where ports live, and all communication at this layer uses ports. So that brings us to layer 3, which is the network layer. The network layer is responsible for handling data transfer between two different networks. At the transport layer, the data is broken down into segments. At the network layer, the data is broken down into packets. The network layer is where the IP protocol is introduced, and probably something you've heard of before. If you've ever dealt with IP addresses in the past, then you've worked with a network layer. IP addresses are how data is routed from all different devices on various networks across the world. Since this layer is responsible for the communication between two different networks, it's also responsible for finding the best physical path to reach that other network. The process of finding the best physical path is also known as routing. More than likely, you have a wireless router in your home for your internet. If you do have one, then that is a layer 3 networking device. Yes, your device performs other functions, but the actual routing that allows you to communicate with other networks outside of your own network is layer 3. This layer also handles fragmentation, which means that if the packets that were being sent were too large, this layer will break them down into smaller chunks called fragments. Once the receiver receives those fragments, they are reassembled into the original data that was sent. It's important to note that this layer does not guarantee that the message was delivered. Those guarantees happened at layer 4 with TCP, and there's also some guarantees that'll come at layer 2. The best way I remember the differences between layer 3 and layer 4 is that layer 4 you're dealing with ports, at layer 3 you're strictly dealing with IP addresses. So if you're in a conversation with someone and you're talking about ports, then you're talking about layer 4. So that brings us to layer 2, which is the data link layer. You're going to notice some similarities between this layer and layer 3. So while layer 3, the networking layer, was responsible for communication on different networks, layer 2, the data link layer, is responsible for communication on the same network. So at layer 4, we had segments, at layer 3, we had packets, and at layer 2, the data is further broken down into what are known as frames. So at layer 3 with the packets, we were using IP addresses for communication. At layer 2, we're using the physical addresses of the devices. You might have heard of this address before at this layer. It's called a MAC address. MAC stands for Media Access Control. The device you're watching this video on right now has a MAC address. Your fridge, your Wi-Fi connected toaster, all of those devices have a unique MAC address assigned to them. MAC addresses are supposed to be globally unique, which they are, but on certain systems you can spoof them, but that's a topic for another time. So besides facilitating the communication on the same network using MAC addresses, this layer also handles the important job of flow control. So as an example, the device sending the data is sending data at a rate of 200 frames per second, but the receiver can only receive data at 100 frames per second. If the sender continues at that high rate, data corruption and loss will occur. The data link layer ensures the sender and receiver are communicating at the proper transmission speed. This layer handles a lot, so stay with me. The next thing this layer handles is access control, and that's done using a switch. We talked about routing and routers, that's at layer 3 using IP addresses. Switching, which happens on a switch, is done at layer 2 using MAC addresses. Since this data transfer is happening on the same network, we're talking about physical ports. MAC addresses allow switches to authenticate the actual device plugged into that specific port, and that it's not some attacker who unplugged the phone in a lobby to get access to the local network. There are ways to bypass this, but in theory, this is the protection that MAC address filtering provides. A subtopic of access control is VLANs or virtual LANs. This is also handled at layer 2. A VLAN is a way to take your LAN or local area network and virtually break it up into segmented networks. The main type of VLAN is a port-based VLAN. So let's take this switch for example. If I have these 6 ports on the bottom here, and I assign these to VLAN 10, and these top 6, I assign them to VLAN 20. VLAN 10 and VLAN 20 will not be able to communicate with each other. If you've ever used a switch in the past, then most likely what you've seen is you plug in whatever you want to any port, every device can communicate with each other. VLANs are a way to separate that communication. This improves the efficiency by making it so the switch only needs to switch between those port groups of those specific VLANs, and it also improves the overall security by being able to isolate certain network devices. I have PoE cameras at my home, so in order to keep those separate from the rest of my network, I have those on a separate VLAN versus the rest of my internal home network. I know that was a lot, but layer 2 plays a big part in the OSI model. So that brings us to the last layer, which is layer 1, and that is the physical layer. This layer includes the physical equipment used in the data transfer, such as Ethernet cables, optical cables, the switches, routers, everything you could think of. It's also at layer 1 where data gets converted into a bit stream, which is a string of zeros and ones. It's at layer 1 where devices agree on how to interpret voltage signals so they can distinguish between the high and low voltage and convert that to zeros and ones. This can be one of the easier layers to troubleshoot, as you're physically identifying what the problem could be. So one of my previous jobs, I used to work in a data center, and one day I was rearranging some cables for some servers, got a call from my boss, a bunch of stuff went offline, turns out I moved the wrong cable. That is an example of a layer 1 problem. Here's a list of some helpful mnemonics to remember these different layers. It can be a little bit easier to memorize them if you're struggling with that. So now onto the bonus layer, layer 8. Never tell your boss about this layer. Layer 8 is management, and I do not mean device management, I mean people management. So to me, this is one of the hardest layers to deal with. This layer likes to cut costs, to save money, they like to make you work on projects that aren't really useful, so good luck. So I don't have much advice on how to deal with this layer, but it is a lot of fun to make jokes that the problem is a layer 8 issue.